So this here is an image that was captured by Perseverance. It's a rover. It was sent to Mars by NASA about like 5 years ago. But initially it was deployed in 2012 and it uses like really old hardware. But as you can see, it's captured like a couple of images and it stitched them together. Now when it was initially sent, the mission was, let's go from point A to point B and let's capture some soil samples and search for ancient microbial life. Yeah. But one of the problems that it encountered was that whenever it used to go from point A to point B, if it was a long distance, tiny errors used to get compounded and it would drift away at least by 100 meters, right? Or 100 feet. But it would end up in the wrong position and it would stop and it would message engineers back home on Earth. And here people would take the laborious task of analyzing information, large data sets, look at the terrain, look at orbital maps, and then finally they would communicate back with Mars. And the whole thing would take hours together. But that all stopped when we came to the advent of AI. When we started off, exploring the domain of space exploration with AI, they installed a couple of software upgrades or AI upgrades. So what they did, they installed a very rudimentary AI software application given the old hardware the rover had. And now the rover is able to make autonomous decisions, right? It was able to explore the terrain. It was able to go further. It was almost like it had a semi-executive brain. So that's what we've deployed. It's distributed intelligence across, 225 miles away on another planet altogether. Now, that is just the start. We've gone all the way from there to deploying it across domains in here at home. So we can start with, for example, computational biology and molecular modeling. Now, although it sounds complex, in the realm of life sciences, it's honestly, AI has like such phenomenal use cases. One of my colleagues, Sahil Wadhwa, he's right here. He's a brilliant data scientist, guys. For the last couple of months, he's been working on this AI application that using NVIDIA and VAST that does protein folding. It can simulate molecular interactions and it can generate novel proteins. Now, to give you some context, that kind of a couple of years ago, that used to be a research topic for a PhD student. We would spend like 3 years altogether trying to understand, what does this particular part of this protein look like? And now, like, the tool can do it under like 2 minutes, right? And moving on from there, we've got like real-time economic intelligence. Talk about fraud detection. We've got predictive AI systems that have gotten a boom with generative AI. We've got systems that can look at fraud in real time, look at trends, patterns, understand patterns, and then kind of come up with a response in real time. And moving on, we've also got like planetary scales climatic simulation. Like you can take complex environments, right, and you can simulate it with AI. And that's the coolest part. We may not know of a crisis that's happening like 10 years from now, but AI can simulate it and also give us ways to form solutions for these challenges. But the thing is, all of this AI expansion is taking place in the backdrop of certain socioeconomic and geopolitical factors, right? There's a certain landscape that's been set. Now the thing is, AI is not being seen as a technological advancement anymore. Yeah, it's more of a strategic advantage. So countries are heavily investing. I'm not going to name countries, but like lots of countries are heavily investing in AI infrastructure, AI research. And the thing is, anybody who has access to these supply chains, anybody who has access to like this large infrastructure is at a competitive advantage, and that translates even to the private sector, right? If you have a company that has AI infrastructure, they have access to semiconductor supply chains, they're automatically at an advantage. Now what that means for us is the thing is, a lot of companies that we do deal with, and a lot of organizations that we do deal with at Boston also, they have traditional IT infrastructure, most of it that cannot handle data-intensive AI workloads, and the thing is, the demand for computers also like surged in the last couple of years, but the supply chain has like very tightly been constrained. But the thing is, organizations can still scale up. You can't just look at it from like, oh yeah, I just want this single use case. I have this data set here that I can like probably use. I have this use case that I can probably, explore. That is why 80% of like pilots don't actually translate into production. They just fail. So, I mean, at Boston, we kind of look at it from like an end-to-end perspective. Now this is a very simplified diagram of like what an AI factory looks like, right? So at the top, you have like the AI applications and outcomes. This is like tangible outcome. This is what like businesses actually care about. You can have chatbots, image generation robots, research assistants, whatever it is, that forms your top layer here. But like in order to generate those outcomes, it must be hosted on like very robust AI platforms. Now this is where intelligence is actually created, right? You have data that is ingested here. Here you have training and inferencing happening. You train your large data sets. You train your large language models on those data sets, and you deploy them in an environment where they're continuously producing output. And when they produce output like that, they also learn and they adapt in those environments. Now, recently we actually worked with a partner called DCube. The platform is called DCubeX. Now, within minutes, I was able to I had about 60, 70 papers on neurological disorders, right? I was able to ingest those papers on there, and I was able to train a Llama 8 billion parameter model on that data, and I could deploy a research assistant in minutes of time. And it was as simple as a 3-step process, and that's how user-friendly it's become to deploy AI. But even if we want to do that in the background, we need to have a solid data architecture. Now, what do I mean by data architecture? The way data is inputted, stored, or retrieved needs to be very efficient. Because when we're dealing with large data sets, now you can have structured or unstructured data. Structured data is easy data, like data that computers understand, zeros, ones, numbers, rows, columns, and stuff like that. But unstructured data is videos, images, documents. And the thing is, over the last couple of years, the amount of unstructured data has been just surging. So we need data architectures and storage models that can actually accommodate that, organize that, govern that, and push that in an efficient manner so that your models can utilize it as efficiently as possible. Now, your data architecture is the base of everything, the foundation of everything is your AI infrastructure, right? This is the physical engine. Now, it can be your physical, it can be accelerated compute like GPUs. It can be extremely fast networking. You need really fast networking because you're running a lot of workloads in parallel, right? So it can be networking. You need massive storage because you need to be able to store all this data somewhere. Now, when organizations come to us with certain needs, right? Most of the times, what we recognize is that they have a use case, but they don't know how to deploy it. They have the AI infrastructure, but they don't know what to do with it. And there's always some element that's missing. And this is what we always advise customers: don't look at it from a siloed perspective. You need to kind of approach it in a top-down manner, right? For example, if a company comes to me, I'm always first going to ask what your pain point is. What are you researching? Where can we help you? Do you actually need AI deployed in your department in order to help you? So we build the company profile, understand the internal stakeholders. We understand what the company needs, the company profile, their funding, their data skills, because not every company has the data skills that is required to exploit that data and exploit that infrastructure. So we assess that, and that's when we move to the drawing board. We create a blueprint of what it's going to look like. And once we've created the blueprint, we draw what like the solution is going to look like, software-wise, hardware-wise, and it all comes together and it's bespoke, right? If we need to always make sure that it's the right fit for the company. And now, once that happens, we always have the option of POC and validation. Now, this is one thing that is really cool about Boston, and something that I really enjoy myself is playing around in Boston Labs. Because here we have like a lot of hardware, a lot of software. Now, any solution that we've blueprinted in the solution, in the planning phase, you can always deploy it in the lab and actually check it out in real life. Like, is this actually working for me? And if it's not working, I'm gonna go back to the drawing board and I'm gonna redo it all over again. But once we're happy with a solution, that's when we actually build. We've got a great tech team in-house. We've got data scientists like Sahil who can produce some amazing tools. And we've also got like great AI consultants. And that's when we like build and then we deploy. And I don't want to put like a percentage on it, but like 90% of like the customers that we do deal with come back to us looking to scale. This is either because they're dealing with more data for the use case that they have deployed that AI system for, or they've identified new AI use cases that they want to deploy in their company to make it more efficient. So that's kind of like our end-to-end solution, full stack solution. Now, this wouldn't be possible, of course, without our AI ecosystem that we're really proud of. We've got NVIDIA here, Richard from NVIDIA. We've got VAST, we've got Bulk, and we've got Basecamp here, who've actually deployed the AI solution. And I'm gonna, from here, hand it to Gus from Basecamp, because they've deployed the solution and it's an actual use case in the real world. And we can actually see what AI can do as a physical use case. So I'm happy to take questions, but I'll do it at the end of the presentation. No, I'll do it at the end of the presentation. But thank you, guys.